A linear equation in two variables is an equation having the form ax plus by equals c or y equals mx plus b, in which x and y are the variables and the other letters represent constants. A solution of a linear equation in two variables is an ordered pair that makes the equation true. Let's look at some examples. First, is the ordered pair 6, 2 a solution of the equation 2x minus 3y equals 6? In order to answer this question, first remember that in an ordered pair, the first coordinate represents the x value and the second coordinate represents the y value. So we can simply replace x in our equation with 6 and y in our equation with 2 and test to see if the resulting equation is true or false. In this case, we have the equation 12 minus 6 equals 6, which is a true equation. Therefore, we would say, yes, the ordered pair 6, 2 is a solution of the equation 2x minus 3y equals 6. Let's look at the second example. Is the ordered pair 2, negative 1 a solution of that same linear equation? Well, in this case, we would be replacing the x with 2 and the y with negative 1 and checking to see if the equation is true. In this case, we have the equation 4 minus negative 3 equals 6, or 4 plus 3 equals 6. That's clearly not true. 7 does not equal 6. So we can say, no, that ordered pair 2, negative 1 is not a solution of the equation. Let's look at one final example with the linear equation written in a different form. Is the ordered pair negative 4, 1 a solution of y equals 1/2 x plus 3? In this case, the y coordinate is 1, and the x coordinate is negative 4. Replacing those into our equation, we have 1 equals negative 2 plus 3, and that equation is true. So yes, that ordered pair is a solution of the equation. The solutions of a linear equation are often shown graphically. If we plot all of the solutions of a linear equation on a coordinate plane, we'll see that the result is a line. There are several ways in which linear equations can be graphed. One is by generating a table of ordered pairs that are solutions. So let's look at some examples of that process. To graph a linear equation by generating a table, we choose some values for x and calculate the corresponding values for y. Then we plot the resulting ordered pairs on the coordinate plane. We need to do this for at least 2 points to determine the direction of the line. And a third point is often useful as a good check as well. Let's look at the example shown on the screen, the equation y equals 4x minus 3, and draw a graph of that equation. All we need to do is choose a value for x and calculate y using the equation. One simple place to start is to let x equal 0 in the equation. This results in y equals 4 times 0, or 0 minus 3. 0 minus 3 is negative 3, so we see that the ordered pair 0, negative 3 is a solution of the equation. So we can plot that point on our coordinate plane. Let's choose a different value for x. What about x equals 1? That leads us to the equation y equals 4 times 1, or 4, minus 3. Therefore, we see that y is also 1, and the ordered pair 1, 1 is a solution of the equation. So we can plot that on our coordinate plane as well. At this point, we start to have an idea of what the line looks like. If we were to connect those 2 points with a line, we would see the graph of this equation. But let's do one more point as a check just to make sure we have not made any mistakes in the first 2 points that we found. Let's let x equal 2. In this case, we would have y equals 4 times 2, or 8, minus 3. That means y equals 5, and the point 2, 5 can be drawn on our graph as a solution of this equation. We can see all 3 points are now lining up nicely. So let's draw the graph of the equation as a line that passes through those 3 points. Let's do one more example of this process. let's graph the equation y equals negative 2/3 x plus 1. Once again, we'll generate a table of ordered pairs that are solutions by first choosing an x value and then calculating the y value from the equation. An easy place to start, again, is x equals 0. In that case, we'll have y equals negative 2/3 times 0, which is just 0, plus 1. So the ordered pair 0, 1 is the first solution that we found. Let's plot that point on our coordinate plane. Now, before we choose our next value for x, look at that fraction, negative 2/3, that's being multiplied by the x coordinate. If we choose wisely, we can make our calculations a little bit easier. For example, rather than choosing x equals 1 or x equals 2, let's choose x equals 3 and replace that in our equation. Now our equation has y equals negative 2/3 times 3 plus 1. The advantage of choosing 3 is that it cancels out with the 3 in the denominator of our fraction, leaving us with negative 2 plus 1, or negative 1, for our y coordinate. So the point 3, negative 1 is plotted on the coordinate plane. Let's do one more point as a check again. Once again, if we choose a multiple of 3, it will make dealing with that fraction easier in terms of the calculations. So let's let y equal 6. In this case, the 6 and 3 simplify into a 2. So we have negative 2 times 2, which is negative 4, plus 1, which is negative 3. So the point 6, negative 3 is on the graph because it's a solution of that equation. Now we see our 3 points lining up nicely, so let's connect them with a line to show the graph of the equation. One final point of note is that every point on this line that we've graphed is actually a solution of the equation y equals negative 2/3 x plus 1. For example, if another point is chosen, such as this point negative 3, 3, which we can see from the coordinate plane, is on the line. If we replace that point in this equation, we'll see that the equation is true, and that that point negative 3, 3 is also a solution of that equation. You can think of the line as a picture of all possible solutions of the linear equation.